Okay, guys, welcome back. Okay, so this morning, hello. Oh yeah. Okay, so this morning we looked at the first one of our filling methods, which was the flood fill. Essentially, the only really application of that is drawing programs, because it's just a little bit too slow. It's too slow, too cumbersome, but it allows us to fill in regions which are enclosed by pixels of other colours. Okay, so drawing packages is really the only place it's used. Okay, so this will bring us on to the next method, which is sort of basic, what all sort of filling is done using. And in the final lecture today, I'll be talking about texture mapping, which also uses this same basic approach. Okay, so this is the idea of scan line filling. Okay, so what we're doing here is a scan line is a horizontal row of pixels. So what the scan line filling method does is it looks at which rows at a time, so starting at the top of the screen and going down to the bottom of the screen, and it will try and fill scan lines, so rows of pixels at a time. So starting at the top, okay, you calculate what's the what pixels on that row need to be illuminated. Then you go down to the next row of pixels, do the same thing, and the next row. So it goes from top to bottom. Okay. The points where a polygon or an edge of a polygon intersect with scan lines. Remember, a scan line is just a horizontal line, the pixels. Where the polygons intersect with the scan line, those points are called scan extrema. So if an edge intersects with the scan line, the x-coordinates of the scan extrema are calculated, and we use linear interpolation to calculate those coordinates. And we'll be looking at the equations for doing that in this lecture. What we can also do is, if we have a concave polygon, we sort those scan extrema coordinates, so the x-coordinates of the scan extrema, in ascending order. And then what we do is we take pairs of scan extrema and we fill in all the pixels between those pairs. So that's essentially what the method is. It's all about rows of pixels. Okay, so for example, here we have the simple sort of four-sided polygon, and there's our raster. So starting at the top point, what we're going to do is we're going to go from top to bottom, and we just fill in all the pixels on each scan line. So in this line here, that's one scan extrema, because it's where this edge intersects with this row pixel, and that's the other scan extrema. So all pixels between those 2 points, or those 2 pixels, are filled in. Let me just go top to bottom, and then once we're finished, we have our filled polygon. So notice there's no outline for this one. Okay, so we don't use it. If you wanted an outline or you wanted to draw something, we don't use it for that. But this is used much more commonly than the flood fill algorithm for virtual worlds. Okay, so this is the sort of official, formal scanline filling method. So what we need is we need a set of vertices. So V1, V2, V3, etc. Those are coordinates of your vertices of your polygon. And you also need to what colour you're going to fill the polygon in. What we can do to start with, and I'll explain why in a minute, is we go around each edge of your polygon and you calculate what is the change in the x-coordinate along that edge. So each edge has a start point and an end point, the vertex. Delta x is the change, or the difference between those x-coordinates of the vertices, and delta y, difference in the y-coordinate of the vertices. So we calculate delta x over delta y. The reason we do that is because these don't change. So as we go down, as I go down this edge, okay, the delta x divided by delta y does not change all along this edge. It's constant because it's a straight line. Okay, so I can do that to start with. So I got in that previous example, I had 4 edges, so I'd have 4 different values of delta x over delta y. Then what you do for all scan lines, so I'm going to start at the top, go to the bottom. For all edges, and then you do a little if statement if the edge intersects with the scan line. So for example, if I'm on a scan line around here, if I check all edges, this edge intersects with the scan line, but this one doesn't. So I don't have to do it for that one. Calculate the x-coordinate of the scan extremer. So if the edge does intersect, calculate the x-coordinate. So you go around each edge of your polygon and determine, does the scan line intersect with that edge? If it does, we calculate the x-coordinate for where it does intersect. Then what we do, we sort the scan extremer into ascending order, so small to big, and then you eliminate all pixels between the scan extremer pairs. So if we have a look at that sort of diagram example, here I've got the same example as I used this morning. So this has got 8 sides. It's quite a complicated polygon. I've chosen this because it has this sort of area here, so it means it's concave. Okay, concave means if I can, for any 2 points on the polygon, if I could draw a line between them and they cross the edges of the polygon, it's concave. Okay, so they've got an 8-sided, so therefore got 8 vertices describing the polygon. Okay, let's say this is my scan extremer, this dash line, sorry, scan line on this dash line, and I go around each of these edges in turn. So V1 to V2 doesn't intersect, so I can carry on. Neither does V2 to V3. Neither does all the way up to there. Okay. But V6 to V7 does intersect. So I check all of these edges to see whether it intersects with my scan line. And the first one it does is V6 to V7, so I calculate what that x coordinate is there. I call it x1. 7 to 8 doesn't. 8 back to 1 does. And I calculate the x coordinate of that intersection point. So I've got 2 scan extremer, x1 and x2. What I then do is arrange them into ascending order. So I've just swapped them around, so I call that x2 and I call that x1 because that's got a lower x value than that. Okay, so I list them into ascending order, and then I plot or I fill in all the pixels between those two, that pair of scan extremer. And that was an easy case because we only had 2. If I move the scan line down to there, so remember scan lines go from top to bottom. So if we get down to here, I do the same thing. So V1 to V2 doesn't cross, but V2 to V3 does. And I calculate that x coordinate there. We call it x1. 3 to 4 doesn't, but 4 to 5 does. So I then calculate this one. Okay, call it x2. V6 to V7 crosses, so I call that x3. And then if I go all the way around V8 to V1, again we've got another scan extremer. So here we've got 4. Okay, so we've got 4 scan extremer, x1, x2, x3, and x4. So the next step is I arrange these into ascending order. Okay, essentially that's going to be x1, that's going to be x2, that's going to be x3, that's going to be x4. And then between pairs of scan extremer, so the first pair is x1 and x2. So between those two, I eliminate all the pixels. Then between x2 and 3, I don't. So it's only between pairs. So 1 and 2 is a pair, 2 and 3 are, 1 and 2 is a pair, 3 and 4 is a pair. If I had 5 and 6, that'd be another pair. So this has the effect of, for this scan line, it's having pixels illuminated, then not, and pixels illuminated, then not. So therefore, it's able to cope with that concave polygon. So that's essentially what the scan line method is. Starting from top to bottom, a scan line of pixels, a horizontal row of pixels. Okay, so how do we calculate the scanning streamer? So if we go back to the Cartesian equation of a line, this is simply y equals mx plus c. So y equals the gradient of the line times x plus c, which is a constant where that line crosses the y-axis. Now, if we know that there is some coordinate xi, yi on the line, okay, we can rearrange this to give us c. Okay, so this c is, if we know this is on the line, therefore we know we've got an expression for c. So if we substitute this right-hand side into this equation, we come out and rearrange in terms of x. So this is in terms of y, and this is in terms of x. The reason why I don't need it in terms of y is because scan line, our coordinate of y is going to be just one less than the previous coordinate. So if I was to start there, if my y was to start there, the next scan line of pixels, the y coordinate would be y minus 1. I'm just going down by 1 pixel each time. Okay, it's the x coordinate of the scanning streamer which we're trying to calculate. So if we rearrange this to make x a subject, substitute in our expression for c into that, and we get this down here. Notice it's delta x over delta y, whereas up here it was delta y over delta x. Okay, so that's why when I showed the algorithm before, it was delta x over delta y. It's because we're calculating what x is, not what y is. So if for a scan line above, you know what the scanning streamer is, and you will, to start at the top, it's whatever the top vertex is. Okay, the next coordinates of your scanning streamer, the y coordinate is just going to be 1 minus the current coordinate of the scanning streamer. The x coordinate just going to be equal to that. Okay, well, it's actually a bit easier than that, because we can actually rearrange this. Okay, so the x would be the current scanning streamer plus a constant, which would be delta x over delta y. Delta x over delta y is constant along the edge, therefore it can be pre-calculated. You don't have to calculate that at each scan line. You calculate it before, because it can be used lots and lots of times. We do have a problem if the edge is horizontal. So if the edge is horizontal, we have a delta y of 0, and we're divided by 0 there. So it does give us a problem. So in that case, we just set m, or whatever this is, to be equal to 0. Okay, there's the output. Nothing too exciting, I'm afraid. It's just the polygon which I showed earlier. But notice there's no outline. So this is what we use where we just want the polygon filled in. We don't want an outline, and that's for most things. If you look at the world around you, things don't have a border. And again, the animation for this scanline fill is not particularly exciting. Just pop over to YouTube for a sec. Here we go. That's it. That was my okay. Coded that into MATLAB. Doesn't do anything too exciting, I'm afraid. Okay, so advantages much faster than flood fill. Remember, the flood fill, you're taking each pixel at a time. You fill in the pixel, then move into a neighbouring one, seeing if that can be filled, or that can be illuminated and doing that. So you're doing it by pixel by pixel. With the scan line, you're doing whole rows of pixels at a time, much quicker. It doesn't need the polygon to be plotted beforehand. The scanline method actually plots the polygon for you. It uses what we call scan coherence, so it does lots of pixels at a time rather than individual. Using lighting models and texture mapping. Okay, so in the third lecture this afternoon, we'll be looking at texture mapping, which uses this. Next week, we'll also be looking at lighting models, which also uses scanline fitting. Okay. Right, at this stage, I'm just going to stop the recording.